Hello guys, we are here today to solve the lead code challenge for the day. For today's, the problem is trapping rainwater. Okay, so we have a scarcity of rainwater and we want to trap that rainwater, harvest that rainwater so that we could use that in future. So how are we going to do this rainwater harvesting? We have been given non-negative integers. Okay, so we have been given an array, and in that array, the array name is height, and in that array, we have been given n non-negative integers. So all integers are positive. Okay, and this represents an elevation map where the width of the each bar is 1. Compute how much water it can trap after raining. See, here for visualization, this has given one demonstration. So here, this height is 0, this is 1, and then again this is 0, 0, 1, 0, and then this is 2. So see, at this place, the water that is, trapped is, is, see, this one is, this column height is 2, and this column height is 1. Water which is trapped is, so in between 2 and 1, the minimum height is 1. Okay. And water trapped is, so here the minimum height is 1 of the left and the, right max. And at this position, the height is 0. Elevation height is 0. So minimum height of left and right minus the elevation height of that point. So this is giving us the, this is giving us the actual water content at that point. See, same for this point also. See here, this height is 3. Okay, this column height is 3, but here this column height is 2. So at this point, height is, this is 3, this is 2. So minimum is 2. So 2, and this point height is 0. So 2 minus 0. So this is the content, water content at this point. Here, the water content is 2 and 3. Minimum is 2. 2 minus, and this height is 1. 2 minus 1 is 1. Here also, the height is, the leftmost height is, leftmost height is 2 and rightmost is 3. Minimum is 2. Between 2 and 3, the minimum is 2. So 2 minus the elevation at that point. So elevation at this point is 1. So 2 minus 1 is 1. So 1 plus, here the height is 2 and here the height is 1. So 1 plus 2 plus 1. So it is 4. Okay. And see, same for here also. Here the, this leftmost height is 2. Here also the leftmost height is 2. So in between this, how much water can be trapped? So that we have to find out. So to find out, what we are going to do, that we are, going to create two arrays. Okay. And the arrays will be, you know, of the same length as the, as the same length as the, you know, the given height array. Okay, like this. So int array left max is equal to new int array and right max is equal to new int array and like this. And now we will iterate through this int array like this. And then what we will do, that left max of No, first of all, we'll have to come calculate the max. So L max is equal to math dot max of L max and height of I, and this left max of I is going to be put in this array. And now for R max is equal to math dot max of R max height of n minus 1. N minus 1 is the last index. Okay. And since I, the value from which I is starting is 0. So n minus 1 minus I. So this is going to be, from the last index, what is the, maximum height till that, the rightmost point. So this is calculating that. And then we are, going to put this in this array, right? Max array of n minus 1 minus I is equal to R max, like this. And then again we'll start this. And then what we will do that, we'll again, int I is equal to 0, I less than n, and plus plus I. So what we will do that, we will do what is the minimum. So for, let's say, at this point we are, so we have to find the minimum of these two things. So, minimum at the left max I and the right max I. So math dot minimum of left max, the given array which we have populated just now, and right max I. Okay, math dot min left max I, right max I, and then the elevation at this point is 0. So that height, this is given in this height array. So this is the height array. Okay, but we have to store this value in some variable. So to do that, what we'll do that we will do water is equal to 0. Okay, and then, so this is giving us the content of water at that place, but we don't want just that. We want the sum total. So that will be the total water trapped inside the trough and valleys, formed by this given input height array. And that's it. This problem is solved now. So once we return this value, this is what we have been asked, and this solves this problem in a very easy way. We have to close this. Perfect. Perfect. So see, in such a simple and lucid manner, this problem has been solved. And this is the characteristics of a solution. It should, make you feel that, even if you encounter this problem next time around, you'll be able to solve this problem in no time. And, this is the, best part of solving this, coming up with a very elegant solution. So with this, I would just like to say that water everywhere, more than enough for everybody to swim and drink. So perfect. With this, we'll close our video. Thanks a lot.